Hello, I am Ibram Sirleaf, and this is my Physics 2211 Lab 3 presentation. Introduction. Lab purpose. The purpose of this lab was to use the principles of gravitational force and equilibrium to see how they work in tandem, as well as test other physical quantities such as velocity and speed. Some of the fundamentals used were gravitational force, which as you can see is the force of gravity, some kinematics such as velocity update and position update, as well as momentum formulas such as P equals mv and the change in momentum over time. The main results got from this lab were that for part 1 was that the mass of the black hole was 1.67 times 10 to the 34th kilograms, and for part 2 the initial velocity of the spaceship was negative 200 in the x direction and negative 800 in the y direction. Methods. Some of the initial conditions for the lab were first the system and surroundings. For part 1, the system was the planet orbiting the black hole, and then the surroundings the only surrounding was the black hole. Then for part 2, the system was both the spaceship and moon, and the only surrounding was the planet that they orbit. And then some of the initial conditions were that the star had a mass of 2 times 10 to the 30th kilograms in part 1, and for part 2, the initial conditions are that there's a planet of mass 6 times 10 to the 24th kilograms, a moon to the mass with a mass of 7 times 10 to the 22nd kilograms, and a ship with a mass of 7 times 10 to the 12th kilograms, as well as a time of 30 seconds. The planet was at the position 0, 0, 0 meters, the moon was at 9 times 10 to the 8th, 0, 0 meters, and the ship was on a mountain of 100 meters on the moon towards the planet. Here's some images showing basically what was done in the lab. Part 1, you can see that this is the black hole and that the planet is orbiting it. And then you can see the spaceship, which is this magenta line. And then you can see the moon, which is this blue line. And then you can see the planet in the middle of them. You can see how each of their orbits change. Here's some of the code. This is part 1. Sorry, this is part 2, and this is part 1. You can see this is where we use some of the momentum problems and like parallel, perpendicular, all that equilibrium stuff. And then here's where we use like the gravitational force with this, and then velocity update and position update. Discussion. So some of the possible errors that we may have had was, first of all, in part 2, since the simulation cuts off after a certain time, it is possible that a collision occurs at some point in the future, just like not what's accounted for during the time value that we set. And then number 2, the values for the gravitational constant and other values are rounded, so they're technically not exact, but that really shouldn't cause much of an issue. And then number 3, the impact of the moon on the planet is not accounted for in part 2, but again, since there's such a difference in mass, that really shouldn't make too much of an issue. Discussion. In this lab, some of the stuff we explored were gravitational force, as well as equilibrium concepts such as perpendicular and parallel force, and finally we ended off with momentum. Questions. First question, in your analysis, you should discuss how the net force and its parallel and perpendicular components are different from the rate of change in momentum and its parallel and perpendicular components. Technically, within both the code and like mathematically, there is no difference between the two since they are equivalent. And then for the second part, this imaginary system has a black hole, a star, a planet, and a moon. If you want to predict the motion of the entire system, what would you need to include in your computational model? Think about all the interactions in the system. Would there be any dominant interactions, or would they all contribute more or less equally? In terms of what interaction would be dominant, it would definitely be the one between the black hole and the star, because they have the most mass, and that would largely determine the movement of all the other objects. And then in order to create a computational model of this, we'd need to find like the forces in between every single object and like see how they influence each other. Conclusion. The conclusion from this lab is that the mass of the black hole in part 1 was 1.67 times 10 to the 34th kilograms, and the initial velocity of the spaceship was negative 200 in the x direction and negative 800 in the y direction. The end.